All right, good afternoon, everyone, and welcome to today's training. Those that are today in the meeting with us today, those that will be joining later on YouTube, thank you very much. And thank you very much to Gearbox, the Gearbox team. Thank you very much to IEEE as well. And Mr. Latif, who is here with us today and will be introducing his team and those that will be conducting the training session today. So welcome, Mr. Latif. Take it away. Thank you.
Great, thank you, Faber. It's a pleasure to be with you once again. We at Gearbox have, spent a lot of time in training in the IoT space. So we're happy to be here to share some information on what it would take to develop your IoT solution. So if you recall, the last two sessions we've had on Wednesday and on Thursday of last week was what is IoT and what is machine learning and AI. So today, what the trainers will cover with you is how do you incorporate those two to create a system that enables you to create a solution around a problem that you're facing. So I will hand over to the team, which is going to be Patrick Limo, Evelyn Otieno, and Max Washira to take you through the content. So over to you, Patrick, Max, and Evelyn.
Okay, hello. We have Eve will be doing the hardware. Also have Maxwell giving us the broad concept concerning the machine learning and IoT. And also I have or later on we'll have engineers from Gearbox. I think they will join us later. So without wasting time, here I will be doing presentation concerning the that's machine learning and IoT for hardware. Just an overview concerning that, because
Patrick, can you hear me?
Yes, Patrick? I can hear you.
Okay. Is it possible to reduce the background noise? There's a bit of it coming through.
Okay.
Yeah.
Okay, fine. Is that okay?
Hello. It's still there quite a bit. I think there's something that's a bit loud.
Yes. Hello.
Hello. Can you hear me?
Yeah, I can hear you.
Yeah. So it's still there quite a bit in the background.
Okay.
Yeah.
Okay, fine. Okay, cool. I think now it's okay. Yes, hello.
Yeah, it's much better now. Thank you.
Okay, fine. So today we'll be doing machine learning and IoT for hardware. So once we talk of machine learning and IoT for hardware, start we expect data from that's IoT device, and that's from a sensor. Then we do analytics with our machine learning model. So what I will really focus today in a very short period of time is more of analytics, and then I will hand over to Eve and Maxwell giving us the broad concept. So we want to talk about accelerating digital transformation through connectivity and cognition, whereby we have digitization, we have connectivity, we have service and enablement, we have the data virtualization, we have data intelligence by cognition. The reason I'm bringing in this is because once we talk of machine learning, when we integrate machine learning and add an IoT, we need data from IoT device so that we can do analytics with our machine learning model. So without wasting time, let me define what is digitization. What is we have it in a mass digitization in mass scale through the edge technologies. That is the actuators, beacons. We have the chips, we have the controllers, LEDs, we have the sensors, specs, and all those kind etc. That's every common thing in our mindset becomes digitized entities and small objects, tangent material that are capable of contributing for mainstream computing. We also have connectivity whereby we have the embedded systems and network to communicate, collaborate, correlate, and collaborate with one device. That's device to device. We have device to cloud, and we have integration drive towards sophisticated application with the maturity of Internet of Things and cyber physical systems. We also have what you call service enablement. We have service enablement. The digitized and connected entities leads to a realization of schools of digital and device services. We also have what you call data virtualization, when billions of different and distributed services interact. Massive and multi-structured data gets are produced and has to be collected and cleaned. Context information has to be embedded with digital data. We have what's called digital intelligence by cognition. We have applying a big, fast, and streaming analytics on data, digital data, systematically is to create a predictive and cognition, prescriptive and personalized insights, which can be looped back to people and system to take timely decision and plug into action with all the clarity, confidence, and correctness. So we have the digitization, which is IoT plus what we call digital intelligence. That's IoT data analytics to machine learning, paves the way for digital empowered and transformed enterprise. So here I have an example whereby when we talk of machine learning to IoT, whereby we'll be applying them in home, that's health, entertainment, security, utilities, and appliances. We have transport, we have logistics, traffic, parking, emergency services, highways, and we have community, that's factory, retail, environment. We have surveillance, business intelligence. We have smart meters. In national, we have utilities, infrastructure, smart grid. We have remote memories, events. Now, all these things are Internet of Things, sensing, analytics, and virtualization tools, anytime, anywhere, and anything. And the reason I'm bringing the example is we're trying to see on how we can have data from sensors or the IoT devices so that you can use it in machine learning. Remember, things to do with machine learning, it's all about data. It's all about data and analyzing data. Yeah, doing all those kinds of statistics. So how can we make IoT environment intelligent? Any IoT environment comprises of a network, resource constraint, and intensive and embedded systems. Okay, cool. So the first one is the Internet of Agent, that's IOA, for empowering each digital object to be adaptive, uh, articulate, reactive, cognitive through mapping and software agent for each of the participating digital objects. The concept of digital twin stroke virtual object is also mature and stabilized. The proven and the potential of IoT data analytics at edge and clouds levels in the prominent and dominant aspects of for knowledge, discovery, and dissemination. The application of AI technologies leads to realization of smarter systems and service and solution. The new concept of smart contracts being popularized through the blockchains technology leads to sophisticated and decentralized application. So that's it. With IoT and machine learning, is in general term, I can say that we need data from the IoT devices to our machine learning models so that we can do analytics. Data analytics towards sophisticated IoT environment. So just do it, maybe read five from here. Why IoT data analytics? Establishes a variety of smart environment, uncover timely and actionable insights for machine learning, enables the realization of smart objects, device, network, and environment, leads to production of pioneering and people-centric application and services, helps to come out with precise prediction and prescription. That's it. That's why we need IoT data analytics. This will come in once we have the data from sensors, then we'll do the analytics in our machine learning. So data analytics public clouds for smart house. So here I'm bringing in cloud system. Remember, I'm doing a broad the concept um, concerning the machine learning and IoT for hardware. So once here we have a cloud, all right. Here also we have a board, it's a Raspberry Pi, and also we have a cloud, the Amazon Web Services, and we also have our phone, and we have home. When we're doing a project for smarter homes, um, as how we check on how we send data to clouds and boards we use, and how we acquire data from those sensors. Then we do analytics. Yeah. So I'm just doing it real quick. Why IoT data analytics and on cloud? Agility, agility and affordability. We have the data analytics platforms in cloud. We have no SQL or new SQL database and data warehouses in clouds. Wide area network optimization technologies. We have also social and provisional network sites. And that's it. Just moving again very fast because we have the distincts and capabilities of IoT data analytics platforms. We have the scalability, faster data ingestion, better read and write performance, the fast and query processing. Okay, cool. I won't read everything because at the end of the session we'll share the material. Um, so here also we have an IoT device as a sensor, and also we have the fog nodes and the cloud, and these are giving us a broad example on machine learning on IoT devices. Um, Moving on also very fast, we have the device category, we have the I category, that is cloud, as internet. We have the NIN computational devices. We have the laptops and machine and computers. We have the low-end computational devices. We have the phones. We have the sync nodes like Raspberry Pi and node other boards. We have sensors and stroke nodes, stroke networks. Whereby we have sensors and networks, IoT networks, for example, SIG phones, and all those other kind of like Wi-Fi. Okay. Why of Prometheus cloud is not suitable for a certain IoT data analytics? So we have a cloud is centralized and consolidated, shared, automated, compartments and programmable infrastructure. So we will not go through that because just giving an overview on machine learning and machine learning and IoT for hardware. So the reason I'm just doing the analytics is because with the main goal there is to acquire data from the other IoT devices to the machine learning. Um, so I'm just going to read one here for then I give the session to go on. So we have the industry use case of Fox and edge computing. We have the IoT edge and data analytics use cases. We have how we are manufacturing. We have oil and gas extraction. We have mining. We have transportation, power and water, renewable energy, healthcare, retail, smart buildings, and drones and flying robots, unmanned aerial vehicles, smart cities, connected vehicles, and in automobile manufacturing, aerospace. There's aerospace industry. Um, yeah, I think that's it for my side. Remember, I was giving a broad concept concerning the machine learning and IoT for hardware. So now I would like to invite you to give us a topic, to give us, talk more about the hardware. That's it.
Good evening, everyone. Hope you can hear me.
Yes, we can.
Thank you. Now I'll just go through this quickly also, and I'll share my screen. I'll be talking about the following pieces of hardware for machine learning. And as we know, as machine learning has advanced, it's no surprise that the industry has tried to keep up in hardware to support the increasing computational workloads. So these include advancements to CPUs, GPUs, that is graphic processing units, as well as application-specific integrated circuits that have been specifically or specially customized to support the calculations needed for DNNS. So these are the hardware for machine learning that I'll be talking about today. We have Google's TPUs, we have Nvidia's GPUs, Intel's tiny machine learning, that is for microcontroller units for inferencing. And we also have cloud computing for training and deployment. To start with the Google's tensor processing units, that is Google's TPUs. It's a tensor processing built SCIC, I don't know if it is S6 or something. And Google uses TPUs, tensor processing units, to accelerate their machine learning workloads in their data centers as part of their cloud infrastructure. And probably someone could ask that where are Google's TPUs found? That's what I've said that Google uses TPUs to accelerate their machine learning workloads in their data centers. You can underline the term data centers. So the first TPU was introduced in 2016, which then evolved into the latest edge TPU that is widely popular today. And the edge TPU has been integrated into a variety of products under the Coral brand, so that it can have. So under Google TPUs, the Coral brands that I'm talking about, we have Coral DevBoard, that is 1 GB RAM version, and we also have Coral USB accelerator and Coral M2 accelerator with dual edge TPU. While sending the notes, I'm going to send all of these via the email, so we'll get them, so don't worry. Is Nvidia's graphic processing unit, and it is a big part of the AI industry for a long time. But again, someone could ask, what do graphics have to do with machine learning? Well, the answer actually lies in the hardware that supports graphical rendering. Compared to a CPU, a GPU tends to have more of logical cores or arithmetic logical units, which allows it to run many operations in parallel. And in theory, this means that GPUs can perform many operations than CPUs, which drastically speeds up the performance of machine learning. And here, the photo is really not that clear, but this is a sample of how graphic processing, Nvidia's graphic processing unit works. And what can Nvidia's GPUs do? It has an impressive line of enterprise or desktop class GPUs based on their own Turing architecture, as well as a selection of developer kits that support machine learning on the edge. Most of them contain features such as CUDA cores, tensor cores, and CUDNN libraries to accelerate machine learning performances. So CUDA cores, it is a short form for Compute Unified, this one here, Compute Unified Device Architecture. and it is used to enable general purpose computing. NVIDIA's CUDA enabled GPUs, that is to take advantage of their parallel processing capabilities. And we have tensor cores. This one is a primary differentiator from NVIDIA in scaling up deep learning, floating point operation per second of optimized performance for matrix calculation and inferencing, basically used for neural network training and performance. And then we have CUDNN libraries. And this one is, it provides developers with an enhanced interface to utilize tensor cores for deep learning applications and networks. So under NVIDIA's edge machine learning, we have some offerings. Since it has a great success with their more powerful GPU lines, the edge machine learning offerings in the NVIDIA Jetson Nano and Jetson Xavier NX developer kits are nothing to scoff at either. They are both compatible with NVIDIA's Jetpack SDK, which includes bootloader, Linux, kernel, firmware, and drivers. We have TensorRT, that is high performance deep learning inference runtime. And we have CUDNN library, which we've talked about up there, CUDA toolkit. And we also have VisionWorks, software development package for computer vision. So the Jetson Xavier NX is the most powerful platform that is offered by NVIDIA for edge development. Basically, it is used for edge development. And it is equipped with an NVIDIA GPU that offers outstanding performance of maybe 6 TFLOPs. I'll share more of this. Then that is brief on that hardware under NVIDIA's. And we have a sample photo here of Jetson Xavier. That is 2 GB RAM. Then the next hardware is tiny machine learning. And it's basically used for edge machine learning inferencing on microcontrollers. This is used for inferencing. And so far we've talked about specialized hardware for training and inferencing. And we know that machine learning inferencing uses far less computational hardware than training. So tiny machine learning, in this area now, we are beginning to see applications that use machine learning inferencing on the tiniest of edge devices. It is a subset of machine learning that employs optimization techniques to reduce the computational space and power required by machine learning models. We have a sample photo here of how tiny machine learning has been used. You can see it's kind of a cover of a photo of a book, the cover of a book. So with the tiny machine learning, it includes even the microcontrollers. And then the next hardware that we have is cloud computing. And I know almost all of us, we've interacted with, the terms cloud computing and what it does. So cloud computing is very flexible. You can use it to perform both machine learning, training, and deployment. So two main things here that cloud computing is used for. We have training and we have deployment. So in training, it performs resource-intensive calculations for model training on large data sets. Then deployment, it is used for hosting machine learning applications with trained models in the cloud, respond to input data from edge devices, and return the output of the models. And we also have features of cloud computing. We have resource pooling. This basically means that the cloud provider pooled the computing resources or can pool the computing resources to provide services to multiple customers. And we also have on-demand self-service. A user can continually monitor the server uptime, capabilities, and allocated new network storage. Then we also have easy maintenance. It basically means that servers are easily maintained and the downtime is very low. And even in some cases, actually, there is no downtime. Then we have large network access. Here, the user can access the data of the cloud or upload data to the cloud from anywhere, just with the help of a device and an internet connection. It doesn't matter where you are. Then we again have, if I jump to the other side, we have security. And this is the best feature of cloud computing, as it creates a snapshot of the data stored so that data may not get lost even if one of the servers gets damaged. The data is stored within the storage devices, which cannot be hacked and utilized by any other. Then we also have pay as you go. This basically means that in cloud computing, a user has to pay only for the service or the space they have utilized. In other words, there's no hidden or extra charges to be paid. And because of also time, we can look at the other features of cloud computing, like automatic system, economical. We have measured service, we have availability. And then we have advantages of cloud computing. I know there are many, but here I just highlighted two major ones: affordability and accessibility. And for example, while purchasing a powerful GPU for machine learning, it can cost several thousands of dollars for modern applications. However, if we use cloud computing where the capital costs are covered by the service provider, we will only have to pay for the computing power we used. In general, this means lower cost for the individual. And then we also have access to data. And all IoT devices are connected through the cloud. So these centralized computers can take advantage of many streams of data. Hence, we can train more robust models and gain more insights into, for example, supply chain performance. In addition, the centralized nature of cloud computing also makes it easier to update workflows and frameworks. And next, we have popular cloud computing platforms. Here also I highlighted maybe the major three ones, the three major ones. And we can also do some more research and you get to learn more about cloud computing platforms. So we have Amazon Web Services, AWS, that is their logo. This is their logo. And it is the cloud computing platform run by Amazon that provides on-demand services. And it also includes data storage and analysis. So Amazon Web Services offers the Amazon EC2 P4D instances that are equipped with the latest. If you look at the Nvidia A100 Tensor Core GPUs, when we were looking at the first hardware, so it uses the Nvidia A100 Tensor Core GPUs. They also offer various AI-powered applications that can really deploy, such as their search and recommendation engines and tools for data extraction. Then another platform, we have Google Cloud Platform. And this one is run, this is the logo. It is run by Google and offers an extensive suite of services for computing, network, storage, machine learning, and IoT. It is similar to AWS since it allows you to provision hardware for offloading machine learning workloads to the cloud. And then these are the three major ones that I was able to kind of I'm able to present to you, but of course there are others like Collab. Yeah, and also there's another one, I think it's called Jonathan Tan or something. So we also have Microsoft Azure. Is it Azure or Azure? It is Microsoft's cloud computing service and similarly offers a wide range of cloud products and services ranging from virtual machines to data streams to IoT. So this platform, it also allows you to build, train, and deploy machine learning models easily while taking advantage of resources, that is cloud resources, I mean. You'll also be able to use Microsoft's own suite of AI products such as Azure Cognitive Search, Azure Bot Services, and Cognitive Services. Yeah, and that brings me to the end of my slides. I'll share the notes on that. I think there's an email. So I'll share everything that I've been presenting from day one.
All right, that's okay. That's okay. All right, thank you very much, guys. We'll have the session at the same time tomorrow, so from 2 p.m. To about 3:30 at latest. So thank you very much. We'll use the same link as well, so that should be all right. So thank you all very much.
Thank you too.